All right, let's dive right into one of the biggest questions we could possibly ask.
You've probably seen the headlines buzzing about this, and it's a huge question. Did NASA just find proof of life on Mars? Now, it's really tempting to just jump to that conclusion, but we got to be careful here. We're definitely not talking about little green men. But what scientists have found, well, it's honestly the best evidence we've ever had for something on Mars that just might need ancient life to explain it.
So our story kicks off in the Jezero crater. The hero of this tale is, of course, NASA's amazing SUV-sized Perseverance rover, which has been methodically exploring the area. And the main clue in this whole cosmic mystery? It all comes down to a single, very strange rock they named Chiva Falls. It's one of those things that just immediately stood out to the science team.
So, a mysterious spotted rock. You've got to ask, right? What was so special about this one rock out of all the thousands of rocks on Mars? Well, it really all started with what the rover could see with its own eyes.
This thing was covered in these really distinct blotches, and the team on the ground started calling them leopard spots. You can see why. It was just such a weird pattern, so different from the surrounding area, that it basically screamed, "Hey, look at me!" They knew right away they had to get the rover's instruments in there for a closer look and figure out what in the world these spots were made of.
And this is where things go from a cool visual mystery to a full-blown chemical investigation. It's time to uncover the chemical clues. The rover basically turned into a crime scene investigator, deploying all its high-tech tools to run a forensic analysis on these spots.
Okay, the first clue they found? Organic matter. Now, finding organics on Mars is a huge deal, but, and this is a big but, it is not a smoking gun. The best analogy I've heard is it's like finding flour and sugar in a kitchen. Yeah, you've got the basic ingredients to bake a cake, but it doesn't prove a cake was ever actually baked, right? So it gets your attention for sure, but it's not the whole story.
But then came the second clue, and this one is much more specific. The spots also had these iron-rich minerals, vivianite and grigite. And here's the real kicker. Here on Earth, you almost only find these specific minerals where microbes have been busy doing their thing. They are classic byproducts of biological activity.
So here's the real story. The thing that makes this so electrifying isn't just finding the organics, and it's not just finding the special minerals. It's finding them packed together, right in the same spot. Think about it this way. You've got the meal, that's the organic matter, and right next to it you've got the leftovers, the waste products. That combination is what takes scientists from saying, that's kind of interesting, to, whoa, this might actually be it.
And if you want let's say, a more direct way of putting it, astrobiologist Dr. David Grinspoon just nailed it. He said it's like finding microbial poop. I mean, it's a perfect analogy, right? It's what gets left behind after ancient microbes could have chowed down on that organic energy source. It just makes the complex science instantly click.
Okay, but being a good scientist means you can't just find evidence that supports your favorite theory. You have to be a good detective, and that means proving that other explanations just don't fit the facts. You've got to rule out the other suspects.
So the science team went right down the checklist. First up, could these minerals have been formed by some kind of high-temperature reaction? Nope. The evidence in the rock itself pointed to a low-temperature environment. So that's ruled out. Okay, next, what about a super acidic environment? Again, the chemistry of the rock just didn't add up. So once you start crossing these other possibilities off the list, the biological explanation is the one that's left standing. It's the favorite theory right now because it just fits all the evidence best.
Now, the reason scientists are taking this all so seriously isn't just about the chemistry in this one rock. It's also about the bigger picture. It's about the location. You might be wondering, why was the rover even in this spot to begin with? Was this just a lucky find? The answer to that is a huge, definitive no.
Make no mistake, this discovery was no accident. It was the result of years and years of incredibly careful planning. Decades ago, satellites orbiting Mars identified the Jezero crater as this super promising ancient river delta, exactly the kind of place where water once flowed and, just maybe, life could have existed. That is precisely why Perseverance was sent to this exact spot back in 2021. And what we're seeing today, it's the direct payoff of all that hard work.
And what's more, these particular rocks are actually some of the youngest sediments that Perseverance has looked at so far. Now, young is a relative term here, okay? We are still talking about billions of years old. But what it suggests is that if life did exist on Mars, it might have stuck around for a pretty long time, surviving in these more recent pockets of habitability.
So finding potential signs of ancient life is one thing,
But this is where the story just explodes into some of the most profound, mind-bending questions we can possibly ask about, well, about everything, even our own origins. Are we descended from Martians?
It's the natural next question, isn't it? If there was life on Mars billions of years ago, could something still be alive there right now? The surface today is a total nightmare. It's frozen, dry, and blasted with radiation. But a lot of scientists are really hopeful that life could still be hanging on in underground aquifers, shielded from all that. Finding a smoking gun for ancient life just makes the hunt for living microbes that much more exciting.
And that leads us to an even wilder idea, a theory called panspermia. The basic idea is that life doesn't necessarily have to stay on its home planet. It could literally hitch a ride on rocks that get blasted into space by a giant asteroid impact, and then travel from one world to another, seeding life across the galaxy.
So if we confirm this is real, that there was life on Mars, we are left staring down two possibilities, and both of them are absolutely staggering. Path number one is an independent origin. That would mean life started from scratch, twice, right here in our own solar system. And if that can happen, the universe is probably overflowing with life. But path number two is a shared origin, panspermia. That could mean that life from Mars traveled here on a meteorite and seeded early Earth. And the implication of that? We, all of us, could be Martians.
And before you write this off as just science fiction, you need to know this. We have found meteorites here on Earth that we know for a fact came from Mars. And back in the early solar system, when this ancient Martian life might have been thriving, these massive impacts were way more common. So the idea of a rock getting blasted off Mars and eventually landing here on Earth, it's not just possible, it's actually pretty plausible.
So as we wait for more analysis and for future missions that might actually bring these rock samples back home, we're left with this one last huge thought. If this finding holds up, if we can prove there was once life on Mars, then the next question is, was it a second independent genesis of life, or was it family? Are we prepared to meet our relatives?